0 to 60 can define a performance car, but it's the fastest 60 to 0 that's the aim of Tarok's brakes. From road cars to race cars, circuits, special stages, or the autostrada, nothing reduces speed like Tarok's brakes. Italy gave the world the art of Da Vinci and Michelangelo. Tarok's has given drivers the art of stopping. For more information and to acquire your own masterpiece, visit tarox.co.uk. Yes, it's me, Mike Stone, and this is the Backseat Driver Podcast. It's the fastest, it's the friendliest, and it's for all the family. The Gas Shocks 116 Trophy and 120 Coupe Cup are the fastest growing race series in the UK, taking in 6 one-hour races and 8 sprints at all the top circuits. Visit 116trophy.com to find out more and get yourself behind the wheel. From a pot of tea to TT motorbikes. From a classic English breakfast to a full serving of classic cars. Bridge House Tea Rooms is the Northwest premier classic car meeting location for cars, bikes, tractors and owners clubs. So no matter what your automotive appetite might be, visit Bridge House Farm Tea Rooms on their Facebook page or call John and Alicia on 07980 444 221 for show details and to reserve your own table and parking space. Anybody who's as old as me will remember the good old days. If you wanted your car to go faster or be more economical, you tuned it up. There were companies out there that would come to your house and tune them up. Then we got on to microchipping, where you re-chipped your car. And you unplugged one and you plugged another in. And lo and behold, that chip would tell the onboard computer engine management system how it wanted the engine to perform. Of course, technology's moved on, and it's moved on to a degree that today's guest, Mr. Qal Shah of BHP UK, is now, I would say, not probably one of the country's leading experts. He could well be global leading expert, given the successes he has achieved. Qal Shah, welcome to the Backseat Driver Radio Show.
Thank you, Mark. Nice to see you again.
Right. How did BHP UK come about?
Oh, we started tuning cars quite a while ago now. It's probably about 20 years ago in year 2000 when the manufacturers started using what we call the modern ECU.
Yeah.
Which means that you can program and update it in situ in the car.
Yeah.
Via the car's OBD socket. And we started that sort of time. So we no longer needed to unsolder the microprocessors that were soldered into the older ECUs.
Yeah.
And we could read the data from the ECU via the diagnostic socket.
Yeah.
Interrogate it, see what it was doing, how it was coded by the manufacturer, and then load a modified mapping.
Yeah, because I mean, one of the things is, or was, say, we'll use the Ford Fiesta as an example.
Sure.
Not for any particular reason, just Ford Fiestas, because it's one of the favourite cars that people do. The engines that some of these Fiestas come with are, in many ways, it's the same engine. It's just programmed differently for the base model, with a performance model, as more or less the same engine. It's just told to work in a different way.
Yeah, absolutely. It's a strategy that manufacturers are using fairly widespread now. The EcoBoost, I think the Fiesta EcoBoost is the one that you're referring to.
Yeah.
It comes in a variety of outputs of 100 horsepower, 125 and 140.
Yeah.
And principally they're the same engine, running the same turbo and running the same injectors, and the management system just controls the power output from the car. So it's fairly easy to make to make the 100 brake horsepower produce 140. So the driving with 100 brake horsepower, drive out with 116.
Yeah.
VW and other manufacturers that does a lot of that. The 2-litre engines and the 1.6. Certainly the diesel engines are predominantly the same. Well, they're identical.
Yeah. Well, the thing about the VW is the engines are the same across the board. I mean, I quite like Skodas. Somebody said, Skoda put a Volkswagen engine in. Well, if you ever go to the Skoda factory and have a tour around, you can actually turn around and say, well, no, Skoda don't fit Volkswagen engines. Volkswagen fits Skoda engines, because that's where the bulk of them are made.
Yeah, most of them are made there, that's right, yeah.
So, I mean, how did you get into this? What gave you the idea for this?
Well, my background is PLC programming and motorsport development, and we just brought the two bits together, really.
Yeah.
Bought a dyno and developed what the manufacturers were doing.
Yeah.
With their programming strategy. It started off very simple. There was in the early ECUs there was very little that you could actually change. There was very little that was controlled by the ECU. On a modern car or a modern bike, everything is run by that ECU. They're so powerful. They control everything from air fuel ratio, boosts. They'll have different maps for different environmental conditions. So they'll have scaling maps that the higher the car is being run above sea level, the more or the less fuel they'll put into it, depending on how high it is above sea level.
Right.
And all of this is controlled by the ECU.
Yeah.
And we can. The data is held. What we call a map is actually a reference table.
Yes.
So if the car is running at X RPM and the driver puts his foot down to Y throttle position, how much boost should we let the car run, and how much fuel should we put into it? Yeah. And from this reference table, if we modify that reference table, we can make it give you a little bit more boost or a little bit more fueling. Manufacturers will also use torque limiting tables, which will limit the amount of torque or the power that the car's allowed to produce. Yeah. Simply upping that from one model to another can sometimes liberate quite a few brake horsepower. Yeah.
I mean, the other thing is as well, besides achieving greater performance, you can, go slightly the opposite way and achieve greater fuel economy, can't you, by using your systems?
Yeah, I mean, what's surprising is you can actually achieve both on the same map. You can make a car more powerful and, in real world terms, give you a better return on economy.
Because the engine is working more efficiently.
Yeah, because it's working more efficiently. Yeah, that's right.
Now, I mean, a while ago, I sat and watched you do this. I mean, it's quite fascinating. You sit at your desk with 3 huge screens, and all the information is programmed into like a unit or what you might call a little form of hard drive that then gets put into the car or plugged into the car for the car to be told this. I mean, where do you start? Where is the starting process? Because say a new car comes out, not one of these electric ones, but I dare say the manufacturers won't be overly keen on handing out this information, will they?
No, so a lot of the information we have to decipher ourselves. So we'll read the machine code or the computer code that's on the electronic control unit, and then we'll start to make modifications on that. Yeah. Obviously, from experience, will tell us what a fueling map, for example, should look like. So we'll modify that fueling map, run it again. This is in the development phase, not on a customer's car. Yeah. So if Bosch, for example, come up with a new ECU, let's say, for example, when they changed over to the EDC 17 family, which is the controller for the diesel engines, they changed the strategy a little bit and they changed the maps. So we'd look at the data on the ECU, and then we'd modify certain aspects of it from previous knowledge and previous experience, and we'd make sure that was doing what we wanted it to do. Yeah. So if we turned the fueling up by 2%, we'd then monitor it again on the dyno and make sure that we were actually getting 2% more fuel and we achieve what we wanted. Once we've established what the maps do, then we can come about with a tuning strategy for each particular make of car.
So do you have cars that you try it out on?
Of course, yeah. We have development cars and development bike. We get them in. More often than not now, we tend to buy our own development vehicles. Yeah. And they can spend a long time on the rolling road. Yeah. And once we've figured it out, then we'll release that. Release that software for customer use.
Which tend to be the most popular cars that people want remapping?
Yeah, it's
I conclude the obvious as not being funny is the boy racer.
Well, actually, contrary to popular opinion, it's not your boy racer. It's mostly your middle-aged man, if I dare say, that's looking for a little bit more performance and a little bit more response and a little bit more fuel economy from his daily run around. Yeah, we do work for motorsport, but it isn't actually the bulk of our work anymore.
Right,
most of our work is for people for their daily drive.
Yeah. Because I know I've known Qal for quite a while, and I once remember you telling me that some guy came in, a youngish lad, I want my car to go better, and your first advice was, after you'd lifted the body, well, take off all that junk that you've fitted to it and it will go better on its own right before I do anything to it.
Yeah, there's we come across that a little bit. Modifications that don't actually achieve anything other than a negative effect. We've seen lots of modifications that can hinder a car's performance. Yeah. What should work in theory doesn't always work in practice. The dyno tells us that an awful lot.
Yeah.
You know, we call it the heartbreaker because it does break a few hearts.
When we see what it's not achieved.
It's not achieved, yeah.
Now, I mean, one of the things is once you've done a car or done a particular engine, I conclude that can be used time and time again for that either model of car or that model of engine.
It can, to a certain extent. What we tend to do is we would use the same strategy.
Yeah.
So if we've done the Ford Fiesta, let's say, for example, and we've...
By the way, can I just put it, there's nothing remarkably wrong with Ford Fiesta.
No, not at all.
It's just a model of car we've chosen to discuss.
Yeah, okay. So once we've figured out how we can improve that particular program on that particular ECU for that particular car, we would use the same strategy because the manufacturers have a habit of releasing different software versions. So you couldn't take the file from one car and put it into another.
All right.
Each car is obviously coded. Each ECU is coded to the car that it's going to be fitted to.
Yeah.
Or coded after it's fitted actually at the factory. But you couldn't take the data from one car and put it into another. It does. All of our work is bespoke to the car that we've taken the read from. Referring to the hard drive you were saying. That's basically the device that reads and stores the data from the ECU.
Yeah.
We take that data, put it into my computer, read and modify that data, and then put it back into the programmer.
Yeah.
And program it back to the car. So the file that we modify is always a file that's taken from that particular car. So each file that we do is bespoke to that particular car.
So whether you've got two Fiestas, two Golfs, two Fiats, or whatever, you will bespoke what you're doing for each car. You won't do it to one and then say, well, fit that program to that one as well.
No, we wouldn't. Like I say, each program is coded to that car. It'll have the chassis number and versions and build dates and immobilizer codes. Yeah. So if you took one file from one car and put it into another, programmed into another, the car simply wouldn't start.
Right.
Yeah, you'd have no connection.
Do you ever have it where you're looking at what you would call, you're taking information from the car, and say a new car, and it won't talk to you? Do the manufacturers ever make it that BHP UK can't talk to their engines?
Yeah, it's actually part of requirements. They're actually required to do that.
All right.
There's always a. That's the first part. First thing we've got to do is establish a protocol to talk to the ECU.
Yeah, because I mean that's one of those things. You open the bonnet on a car these days, and it is not what I call customer or owner friendly. It's under a great big piece of plastic. The last thing they want is anybody apart from their technicians or fitters to do anything to it. Yeah. I conclude when a new car comes out, one of the things you do is you go and have a look at one if you can.
We do, but more often than not, what we're looking for as opposed, it doesn't have to be that particular car. What we're looking for is the ECU family that controls it.
Right.
So if a car's running a Bosch or a Magnetic Morelli ECU, it's access to that ECU that we are looking for.
Right.
Cars even that run the same ECU can run different mapping strategies. Yeah. They will all have their own different mapping strategies, but the architecture of the ECU generally stays the same.
Yeah. So it'll be quite interesting to actually see what they've done. But one of the first things you'll be able to notice is they've changed this.
Of course, yeah. This has changed and that's changed. And we're going through quite a phase with motorbikes at the moment where...
So I was just going to say, that's the one thing. You now do motorbikes as well, and it's proving extremely popular, is having the motorbike engine tuned up a little bit.
Yeah, it certainly is. I mean, we added motorbikes we added them commercially about 3 years ago. We were playing with motorbikes prior to that, but that was just a passion thing, really, just more of a hobby for myself and a couple of the lads that work here. Yeah. And we decided to release it 3 years ago now. And with motorbikes at the moment shifting over from Euro 3 to Euro 4, and this year shifting over to Euro 5, they're very restricted in the power that they produce. There's a knock-on effect that a lot of the bikes have huge flat spots in them. The throttle response is getting fairly poor. And on some models, you are renowned for having a jerky throttle.
Oh.
And when we program it out, that's on a motorbike. We don't make huge gains as far as power is concerned. We might make 5 or 10 brake horsepower extra at the top end. Yeah. But the biggest gain is how much we improve the power delivery and eliminate flat spots.
I conclude that is a lot now for the simple reason when I grew up, throttles were on cables. Throttles are no longer on cables these days.
No, no, this is where
they're like an on-off switch.
Yeah, the term fly-by-wire comes about. It has its advantages and it has its disadvantages. The main advantage is, of course, that time and technology waits for no man, and the technology has moved on. The reason now we can produce a car, or cars are produced that produce 200 brake horsepower, don't need servicing for 20,000 miles, and will run for 200,000 miles, is down to how well they're controlled and the advancements of technology.
Yeah.
And obviously, when you produce a car that's making 200 or 300 or 400 horsepower, we've got motorbikes that are producing 200 horsepower.
Yeah.
And you've got to make them in a manner that's drivable on the road.
So we're going to say 200 brake horsepower car is relatively lively.
Yeah.
A 200 brake horsepower motorbike has long since surpassed a bit lively. I mean, it's got to be quite a thing to ride as a 200 brake horsepower bike, if not more.
Yeah, they can be very, very fun to ride. They can be a lot of fun to ride, and they can be very lively. But if it wasn't for the electronics and the traction control systems and the anti-wheelie, I don't think there's many people on the road that could actually ride them.
Yeah,
there are many people I'm sure claim they could.
Yeah,
but I certainly think all my rider aids are fully switched on. I'll show you around the workshop and some of the development bikes we've got later. But we've got an Aprilia Tuno in there at the moment, and the programmability on it is just absolutely amazing.
Yeah,
they've just come on so much. We've got variable traction control, wheelie control, different throttle maps for wet conditions and dry conditions, and if you want.
Can you actually set these? Is there like a program on the bike where you can? I mean, you can do it with a lot of high performance cars. You can set different things, or some of the different systems. You can set them to suit condition. I conclude, can you do that with the bikes as well? Yeah,
it's the same, and even more so used in bikes. Most bikes will have either a wet mode or a road mode, or a track mode. I mean, BMW have a wet, a road, and a race, or a dynamic mode as they call it. Some of the bikes have an enduro mode so that the power delivery is more in tune with running off road and such like. Yeah.
Now, I mean, one of the things I called here a few weeks ago to raise this interview, you were on the motorbike's rolling road. The interesting thing is the bike is strapped onto everything to make sure it doesn't pop off, and then you're surrounded by computers you keep tapping into the computers. Is that telling the bike what to do?
No, at that point, I think if I recall, what bike did we have? Was it a BMW?
No, it was a KTM.
Was it KTM? Right, okay. So I think what we were doing, we were just reading and establishing base data off the bike. So we'll run the bike at wide open throttle.
Yeah.
And then we'll run it at 10% throttle and 20% and 40%, 60, 80, and 90 and 100% throttle. And then we'll log that data. So we generally have 3 systems running at the same time. We've got the dyno that's measuring the power. Then we'll have analog inputs into the dyno, so we'll be measuring the lambda, throttle position, sometimes on the dyno, RPM, and then we'll have a third system in through the OBD socket that will measure pretty much everything else. So we'll be measuring injector duty cycle, advance, RPM, and throttle load. And see how that changes as we're accelerated. And you will find that you will get to a certain range in the RPM that the manufacturers had to introduce lean spots in. They're the lean spots that we're looking for, and the flat spots in power delivery. They're what we're looking for and looking to improve. So I think we may have done probably 7 or 8 runs in that time, just at different throttle openings in the same mode. So I think we ran that in track mode at the time, and then we repeated it again after you'd left in all the other modes. So we've got a good base of data that we can work with. Yeah.
These built-in flat spots that you were saying the manufacturers build in, do you build them out?
Depending on what the bike's going to be used for, yes, normally we build them out. What we're looking for is a nice progressive bike that rides well on the road or the track, depending on what you want to do with it. We're not looking for something that's going to produce huge amounts of erratic power with an erratic power delivery that becomes virtually unrideable on the road. So we had a Panigale not so long ago, the Ducati, and they're quite sedate at the bottom. That was a 180 brake horsepower bike, but below 7,000 RPM. Ducati have left it on purpose, intentionally, quite sedate, so it's quite nice to ride.
Yeah.
After that, when you wide open throttle, it becomes a bit of an animal.
Yeah.
It does actually have 3 fairly pronounced flat spots in it. We've got the video on YouTube actually as to what we did with that bike. And the biggest aim of that strategy was to get rid of those 3 flat spots and give you a linear power delivery above 7,000 RPM while maintaining the rideability below.
Yeah.
I did test ride that bike myself afterwards, and it was a good improvement. It was one that I didn't want to hand back to the customer. Let's say.
I mean, just out of interest, when you've done this especially to a motorbike, when the customer comes back, do you talk them through it and say, look, this will be a different bike for you to ride now? Be careful with it until you've got used to it.
No, it's on the whole, it's actually the other way around. People, the feedback that we get and what we're trying to achieve is to make it as nice to ride as possible.
Yeah.
When you take those flat spots out, as you know yourself, the power delivery just becomes nicer.
Yeah.
It becomes actually easier to ride.
Yeah.
You know, we may have made a little bit more power, but it's delivered in a much nicer package.
Yeah.
And that's what we're looking for.
And the one thing is about BHP UK, as time's gone on, where you were, shall we say, not a one-man band, but a one building man. I mean, you've now expanded quite a lot, haven't you? I mean, you do have people who franchise your products as such.
Yeah, so
even though obviously your product isn't actually a physical thing in many ways, is it?
No, it's a software upgrade for your car, really. So
I mean, that rather degrades what it is.
Yeah. Yeah. And we certainly on the car side, we franchise it around the world. We've got about 280 franchises now.
Yeah.
So you're never really far away from one of our remaps.
Yeah.
Predominantly in the UK and Europe at the moment, but we're spreading our wings a little bit further afield. Yeah. We've got dealerships in America and Cyprus and Greece.
Oh, right.
Yeah, we've got a couple in Italy and in Germany. Yeah.
But like you were saying, maybe not as much these days, but your involvement with motorsport. I mean, it's both 2 wheels and 4 wheels is your motorsport involvement, isn't it?
Yeah.
Besides doing it yourself to a degree, or maybe not as much these days.
No.
Well, they always say with old age comes common sense. I don't know whether it does or not, but you just realise, you think, maybe I'm better off sat at home watching telly than going out these days.
Maybe it's because we're not physically capable. I'm not so sure about the common sense, because I do look at my friends and my group of riding buddies and think, have we actually attained any more common sense in the last 30 years? I don't know. So that's debatable. But yeah, as far as motorsport's concerned, we've done tuning for factory race series. We did some programming for SsangYong.
Because you were involved with that rather regrettably. It only seemed to last about a season, the SsangYong pickups.
Yeah, that was a good series. Unfortunately, SsangYong decided not to carry on with it. I think it was more to do with just the way that the company wanted to go, really.
Yeah.
But that was a good fun series, watching these SsangYongs go around Cadwell Park almost as fast as a Mini. It was a good series. Unfortunately, it didn't last. But yeah, we did the mapping strategy for the race teams, and they all had to run the same. It was a one series. It was a one manufacturer series, so they all had to run the same maps. And we programmed them and made sure nobody was cheating, and did spot checks and such like for SsangYong. Yeah.
And what is your current involvement in motorsport?
At the moment, we're a bit limited to single teams, individual teams.
Yeah. I suppose, not being funny, one team won't want another team having the technical know-how or advantages that they have, which I suppose, unfortunately, automatically restricts you, doesn't it?
Yeah. So we can't have any conflicts of interest. So if we're doing a certain series, then we stick to the one team.
Yeah.
Spend a lot of time in the off season, so we're coming up to the off season now, and getting the cars back on the dyno makes it and just carrying on with the development. Yeah. Feedback from the driver and see how we can improve, or if there's obviously any modifications. So we do some single car teams. Yeah. See what sort of improvements they can make over the off season. Yeah.
So, what improvements do you tend to find that you can do to them?
But the bulk of it is to make it run right for the modifications that they've got.
Yeah.
Certain drivers will want it set up slightly different to other drivers. Yeah. And that's principally where we come in, and get the car, one, producing the power that we can make it produce. Yeah. And two, make it as driver friendly or as focused to that particular driver as we can. Yeah. A lot of it is listening to the feedback from the driver.
Right. So you'll sit down and chat with them as to I mean, it's like anything else. Every driver likes his car set up differently. Because there was the famous thing with in Formula One with Ferrari. Michael Schumacher had his cars set up in a way that hardly any of his fellow drivers and teammates could actually drive the car. Eddie Irvine came along as his teammate, and much to Ferrari's surprise, Irvine used to like a car set up how Schumacher had them set up. But that is a sheer rarity. So most cars are set up individually. So when a driver says he wants it set up this way, how do you go about with what you do, setting it up that way?
Yeah, so we will set up the suspension. The geometry is all set up by somebody else.
Yeah.
But there's a lot we can do in the maps to set it up exactly how the driver wants it, and it's set up in a way that the driver wants the power to be delivered.
Yeah.
But yeah, there's many ways we can do that, whether it's restricting the power or increasing the power at a certain RPM.
Yeah. Now, as technology's moving on, I mean, I'm known for not being a particular fan of electric cars, but I've nothing against the hybrid. I think the self-contained hybrid is actually quite a good idea. How are you adapting to work with cars that have, shall we say, two power supplies in one?
Yeah, so the one that we've developed recently is the BMW 330e. Runs the same engine as the 330i, which is actually the same engine as the 320i, and just set up different. And the engine on the 330e is down tuned a touch to be when the power's made up by the electronic system.
Yeah.
Now we are actually already doing work with electronic cars, with electric cars. Again, with the electric cars, it's more to how the power's put down.
Yeah.
We can alter the throttle mapping for that. But on the hybrid cars, we can certainly still tune the internal combustion engine.
Yeah.
Exactly how we want it, and exactly how we have been doing for quite a while.
Right. So do you work it out so the electric bit comes in at a different stage, or do you just work on the theory? We'll work on the petrol engine and leave the electronics to their own devices.
On the hybrids at the moment, we tend to work mostly on the internal combustion side of things.
Yeah.
We will do certain things to integrate them a little bit better or a little bit different.
Yeah.
But technology moves on, and we're part of that. We're a child of technology, aren't we? The whole firm came around because of the advancements in technology. Prior to us, people were setting carbs up, and that changed, and things are going to change again. Then things will.
Well, that usually the other thing into setting carbs up. You go out for a run round, come back, bonnet open, screwdriver out, fiddle, fiddle, fiddle.
Yeah. Or if you were really brave, you'd be fiddling with it while it was on the dyno, sitting in the engine bay while your friend was running the car at full shot on the dyno. It took a little bit of bravery. I don't know if health and safety would be so happy seeing that now. But yeah, I mean, at the moment on the dyno, we have, if we've got customers watching, we have to have a safety officer and such like. I don't think we'd get away with tuning them like that anymore. But
I mean, there are stories of cars occasionally popping off from years ago, wasn't there?
Yeah, fortunately, we've never had that yet in our workshop. A lot of the time, it's user error. They're just not strapped down right or checked properly. We tend to run a fairly strict policy. And it's just a tick sheet you work through and a procedure that you work through. You stick to the procedure. You have very, very little failures.
Yeah.
We've had cars move around a little bit, but we've never had anything jump off the dyno.
Yeah.
We use a double strapping system, so you can have up to 3 points of failure before it should move.
Yeah.
And we don't see any failure anymore.
Yeah.
Touch wood.
So, because I mean, besides doing ordinary cars, you've had some quite impressive vehicles through here, haven't you, over the years?
Yeah, we have. Yeah, we've had some. Everybody in the office has put the mouse down to come and have a look at. Yeah. We've had some decent stuff in recently.
Now, what lies ahead for BHP UK?
At the moment, we're just getting ready to go to the Motorcycle Live show in December. Hope to see some of you guys down there. We're developing the bikes. We're still developing lots of stuff on the cars. We're developing the network, and we're already starting to look at electric vehicles.
Yeah.
I think we have a common an opinion on electric vehicles at the moment, but it's certainly a part of the future. Whether it is the absolute answer to the world's problems, I'm not 100% sure. I've certainly got some reservations myself, but it is a market that we're having to look at, and we'll see. We'll see what the future brings, really.
I mean, batteries are batteries, and as we all know, it's a bit like I use the famous mobile phones with the apples on the back of them. As time goes by, you don't get as much battery life. I suppose from your point of view, the way to tune an electric car is to improve its range, because that is one of the main criticisms, is range and lack of, and B, how long it takes to charge the thing up again. So I conclude that from your point of view is two of the most important things to look at.
From our aspect, as far as tuning is concerned, I think it's going to be more to do with the management of the power that is available. With batteries, obviously batteries are moving over from nickel cadmium. They've never really been used in vehicles, but if you remember the old milk floats,
yes.
So when we were younger, we're using lead acid batteries, which is why the power you could get from them was so low. They could carry on all day, but they could only do about 4 miles an hour.
They weren't exactly quick, were they?
No, they weren't.
No.
And that's just down to how much drain you can get. I'm not an expert on the subject, but I know that lithium polymers and batteries have just evolved exponentially quickly, and at a time where you could draw 2C, which means you can draw twice the current off the battery out of it. Whereas now you're looking at battery. Don't quote me on this. You're looking at batteries that are capable of 50 or 100C.
Yeah. So
if you've got a 100 amp battery, you could draw 10,000 amps from that. 10,000 amps an hour. Obviously, it wouldn't last very long. It only lasts 100th of an hour.
Yeah.
So the chemical structure is changing and the capacity of the battery is changing, but then you get degradation, which is another.
It's like I said about mobile phones. Your smart device, brand new, would take it 3 years down the line, doesn't last as long.
Yeah, I mean this is a like I say, it's not my area of expertise.
Yeah.
I've come across it in different hobbies that I've had, but yeah, there have been great advancements in battery technology. Whether they're going to give us the same options as an internal combustion engine, I think the future is going to tell us that.
I'm a great believer in hydrogen cell will probably be the way to go as the alternative, because it's just in my opinion, far more efficient. Some of the systems that are muted whereby you can change the hydrogen cell over. It's about the size of a decent briefcase, and away you go again. That, to my mind, sounds sensible.
Yeah. It's the charging times, isn't it, on the electric cars?
Yep.
I drove down to Oxford with a friend of mine from the north up here in an electric car, and lo and behold, we couldn't find a charging point. And when we did find one, it wasn't working. It was out of order.
Yeah.
So it added 2 hours to our day finding a charging point that was working and waiting for it to charge enough for us to get back from Oxford. Whereas in internal combustion, obviously, it would have been 5 minutes at the petrol station.
5 minutes at the petrol station.
Or if you've got changeable batteries, then or changeable power cells. In the case of just putting a different power cell in.
The main winners at the moment with trying to charge a car up and find one are the people, are the coffee shops and the services. They must make a fortune out of people charging the cars up, going to have a cup of coffee.
Yeah, I guess so, because that's what we did. That's exactly what we did when we were sat there waiting for this jack to charge up.
So, if somebody wants to get in touch with BHP UK, how do they go about it?
You can find us on the net, bhp-uk.net, or you can ring us directly on 01282 77 9000. We're always happy to talk petrol, or diesel, or motorbikes, or cars. I think really the success of the company has come from really our passion for cars. We do it because we want to do it. It's a hobby for me. It's a real passion thing for me and the guys here. So we're always happy to talk petrol.
Qal Shah, thanks so much for joining me on the Backseat Driver Radio Show. It's always been it's a pleasure to chat with you, a fellow petrolhead and a fellow internal combustion engine enthusiast. Qal, thanks for joining me on the Backseat Driver Radio Show.
Thanks, Mark. I hope to see you again soon.
Rarely beaten on price, never beaten on service. Whether it's cars, bikes or commercials, Hodder Tyres are the best in the business. And when it comes to tyre expertise and advice to supplying the correct tyres for your vehicle's specific requirements, nobody comes close to David Lakin and the Hodder Tyres team. So give them a call on 01200 613 192 or visit the website at hoddertyres.co.uk.